Okay, hello everyone. Welcome to Always Coding. This is our weekly hacky hour. I'm Komal Devjani, a developer advocate at AlwaysAI, and I'm joined today by Eric Van Bueller, who is the principal software engineer at AlwaysAI, and Lila Milani, who is a developer advocate and also software engineer at AlwaysAI. So welcome both of you. So today's topic is focused on how to build a customized video streamer with AlwaysAI. And before we get started, I'm going to show you what the streamer looks like, and then Eric will walk you through how you can customize it. So I'm going to share my screen really quick and show you how to get started with AlwaysAI. If you haven't done so already, make sure you've signed up and registered for an AlwaysAI account, which will navigate you into your dashboard. In your dashboard, you can learn how to train a model, create a project, check out some of our popular starter apps, or run a sample project, which is the Hello World face detector. What you want to do on the dashboard is install the AlwaysAI CLI. So click Install CLI, hit Next, and then click that big red button, Download for Mac or Windows or whichever operating system you're using. So to start the streamer, we're going to run a project. So let's navigate into the projects. And I've created a project for Hacky Hour, so I'm going to navigate into that. And to start the streamer, what you want to do is copy the first command here and make sure you've added the model that you want. So copy the first command here, hit paste, and then enter. And then I want to save this on my local computer. Next you want to do is AI app install, and then AI app start. Okay, and it looks like we have the streamer URL, which we're going to copy and paste into an empty web browser. And as you can see me, you can find the TV. And then if I maybe mess around with the lighting a little bit, it can probably find my couch. Probably not. So lighting matters. So yeah, that's what the streamer looks like. And then Eric is going to walk you through how to customize it. And that's Charlie in the back stretching. At any point during the hacky hour, if you have any questions, feel free to write them down in the Q&A section or raise your hand and we will unmute you. So with that said, Eric, we are ready for your presentation.
All right, thank you, Komal. So yeah, let me go ahead and share my screen. All right, can everyone see my screen?
Yep.
Cool. So I've got a couple slides. I'm not going to bore you with slides, but just wanted to give a little overview of some stuff. And so, yeah, so I'm going to go over some different ways to get your video stream out of your AlwaysAI app and into other things like a browser or a third-party app or a server, all those sorts of things. And so let's see here. So I was going to just go over a few different system architectures you could have or run into, some of the different streaming technologies, and then using some of the AlwaysAI tools such as the streamer and the MJPEG video writer. And then one demo that I'd like to give if we get there is using ZeroMQ, which is a message protocol, and the MJPEG streamer with AlwaysAI to kind of build one of those systems. And yeah, like Komal said, this is meant to be like informative for the community. If you have questions, jump in. They don't even have to be directly related, just yeah, we're here to answer your questions and stuff. So hope you guys find this as interesting as I do. So yeah, a couple of the system architectures you might see. One is the app as a server itself and sending the video stream to like a browser, for instance. And this is how the streamer itself works, as you just saw Komal use. So what happens there is that the app is starting up a SocketIO streamer, and that is, and also an HTTP server. And from that HTTP server, you can connect from your browser and get your video stream there. One limitation is that it really only works with our streamer, the SocketIO connection, because it's kind of specially designed for our use cases. So this isn't something you could really build your own other endpoint with. And I'll show a little bit more of that once we look at the app. One thing that you can build your own endpoint with is the MJPEG video writer. And so what this does is a little bit similar to the streamer, except it's using an HTTP MJPEG stream instead of SocketIO. And so what we're going to see is that the app itself, it still starts up a streamer, or sorry, an HTTP server that's hosting this MJPEG stream. But then that MJPEG stream can be used in a third-party app. It's kind of this example over here, or in a browser. And it's really easy to work with that. So I'll give an example of that in the code in a bit. And then the more like expandable system has the app as a client with the standalone server, and then going to a browser, or that could go to a third-party app, really anything. It could be just all processed at the server. And this gives you a lot more flexibility because these two links can use different technologies. One thing that you'll find when you get into this is that sending data between two apps is a whole lot easier than sending data between an app and a browser, because when I say data, I'm specifically referring to the video stream, but it's probably more general than that too. But out of all of the different streaming protocols out there, only a subset of them are implemented in the browser. So that's one of the challenges that we run into when we're trying to get our video stream into a browser. When you're looking at third-party apps, VLC, for example, or there's some others out there, like we were looking at a company called Rokos. They can take these different types of video streams in and process that video data as well. So let's move on. So I just grabbed this little graphic. It's a little bit hard to see on the gray background, I realize, but from this website down here, I think it's pretty interesting. Kind of shows the different latency that you would see between these different technologies. And so most of the like GStreamer and stuff, if you've used that, you're probably using some like RTSP or RTP. All of those kind of fit in this low latency section, but still not low enough for like if you were trying to actually make decisions with that stream at a really high rate, that latency might be too low. I would say that ZeroMQ is probably somewhere in this section by WebRTC, but as far as I know, is not implemented in the browser. WebRTC is one that's actually implemented in the browser, and I haven't tried it yet. It's high on my list, but I believe that's how a lot of the browser-based telepresence apps work, using WebRTC under the hood. So with HTTP, you're going to definitely see some higher latency, and you probably, if you've used the streamer or other similar apps, you've probably seen some of that. Even with the MJPEG stream, depending on your connection, you could get a good amount of latency there. So yeah, so let's jump into some code, and I'm just going to go over some stuff fairly quickly. These code examples are quite simple, and they're all available for you to grab either from our starter apps or on our GitHub. So I'm going to start by just going through the streamer as Komal showed, and then show how to use the MJPEG video writer with that as well. So in the documentation, I'm going to head over to the EdgeIQ API, and in the streamer section, there's a good overview of how to use the streamer, and I have the NVIDIA real-time object detector over here. So let's, and this is just from our GitHub page. I can share the link for that actually. So this is the AlwaysAI public GitHub, and we have this NVIDIA real-time object detector. I'll just put this in the chat. I'm going to run this on an Xavier NX. You can tweak it to use the DNN engine, or just get the regular object detector if you want to run right on your laptop or desktop or whatever. How do I get to the chat thing here? Maybe I can't.
I can share that.
Okay, great. Thanks, Komal. So the streamer is instantiated in this as a context manager here, and it's just instantiated as the streamer. And then if we look through the description of some of the methods, the important one that we're using here is send data. That one sends an image and text, and that's what you see come up on the browser. So what we're going to do in this nice and concise app is that we're grabbing a frame, doing object detection, drawing the bounding boxes on the frame, and then after that, putting some text together and sending the new frame and the text up to the browser. And I can just run this real quick so we can get a visual of it, but it should look pretty much the same as what Komal showed. So I'll run app install. I think I already configured it to run on the Xavier NX, but we'll find out. Okay. And it looks like we'll have to give the Docker pull a minute. So let's see if there's anything else important here. So the check exit is another useful part of the streamer, and that checks to see if that stop button has been pressed so you can exit your app gracefully. And that's the most interactive part of the streamer. So one thing I always like to point out is that, and I alluded to this earlier, but the streamer is using SocketIO, and it's kind of a specially designed connection to use with our starter apps and kind of with debugging and stuff like that. When you want to go to something more production aimed and stuff, you're going to want to build your own video streaming thing. And that's kind of the whole reason why I'm going through all of this, but I just want to give you the starting point here and let you know kind of how these things work. And actually, if you want to design something with SocketIO end to end, we have another GitHub app up on a GitHub repo called Video Streamer, and that's using SocketIO the whole way. I'm going to show one today using ZeroMQ, and it's a lot more efficient, and you're going to get a better frame rate out of it. But you look, so SocketIO, if you're unaware, is a streaming HTTP protocol. So, or I don't know exactly what it's running on, but basically it's designed to do streaming rather than just request and response such as HTTP. So one thing you're going to see is that it does work for these video streaming applications, but it's much higher overhead than some of the video streaming technologies that are especially designed for video streaming. So you've probably witnessed that if you have a poor network connection and you're running an AlwaysAI app using the streamer, you might see that it gets really laggy and stuff like that. So we'll see how this goes. So I installed it. Let's go ahead and start that. And is this big enough for everyone to see? I enlarged it a little bit, but how does it look, Komal?
Yeah, I think it's fine.
Okay, great. Okay, so we've got the streamer, and it'll probably take a second because it's loading YOLO on the CUDA stuff. So there we go. And I always laugh. So it gets books on my shelf behind me, but it thinks I'm one huge book today. I haven't seen that before. So I'll take that as a compliment, I guess. But
Eric, can you briefly describe your camera setup? Is it a standalone camera?
This is a webcam connected to a Jetson Xavier NX. So let me see if I can hold the Jetson device up to the thing without, oops. So I have a CSI camera hooked up, but the webcam looks a lot better. So there's my Xavier NX.
And is it possible to connect it to a Blink or like a Ring camera?
To connect it to what?
To a Blink or a Ring camera?
Oh, I don't know. Is that, are those IP cameras?
Well, I believe Ring is like the Amazon camera, if I'm not mistaken. And then Blink, I'm not sure if it's an IP camera. Let's see. So yeah, it's like a plug-in smart security camera.
Oh, cool. Yeah, if you have an IP video stream, that's another thing. Let me just go over that real quick. So we have this video stream API. I'll open this in a new tab. And so webcam video stream is what we use a lot in our apps because a lot of times you have a webcam hooked up. But if you want to use an IP video stream, we have a class for that called IP video stream. And what you do is you just provide the URL and the port and any credentials you might need. If a lot of IP streams have like a username and password that you need to provide as well. That's just all in a string in this class instantiation. And And that should work. That should allow you to process those frames from that other camera on your Jetson device or whatever other device you have. And then from there, you can, the part that I'll be going through is how to get that onto, how to view that in your browser and stuff. So the streamer is there for you, and it always can get you that first step, you know, to do some debugging and testing. But the next step you might want to do is to try out the MJPEG streamer. So, but before I go there, any more questions about the IP cameras and stuff?
And I don't know if this is specific to the IP cameras, but I believe AB had a question.
Sure.
AB, do you still want to ask your question?
No, I just wanted to make a comment there about the Blink cameras and the Ring cameras. So if I don't have possess them myself, but Eric already answered that if there's an IP interface, then it's possible. But the one thing, just a fun fact is, you can write an if you want to access them as well. So you can write a skill in Alexa as well, which exports an API to get that stream. So basically, it pairs up with the camera locally. So because your Blink camera is authenticated, your Alexa, if you're running on a Raspberry Pi, maybe. So I'm talking about something DIY stuff, not like off-the-shelf thing. Off-the-shelf will definitely work, but I'm thinking about if you write and have an AWS Alexa port it on a Raspberry Pi, you can definitely have that kind of linking done. And then once you have it on Raspberry Pi, you can have process that stream using AlwaysAI app, which can run in parallel on the same Raspberry Pi. And you can do also good whatever ideas. So the possibilities are endless. So you can do that.
Oh man, so a lot of fun projects, project possibilities there. Thanks, AB.
Yeah, you can see. Yeah, so there's a lot of potential there. Like, yeah.
Amazing. Thank you, AB. And to add to that, Philip Ha said the Ring camera is an IP security camera, but it has a restriction and won't let users tap in to view the live stream from their own software. So just something to keep in mind.
That's a bummer.
Yeah, but yeah. Oh, I think AB has another thought.
Yeah, so the thing is, yeah, you cannot tap in through that. That's what my thing. So you cannot tap in through any third-party software. But if you write an Alexa skill, because that skill is authenticated with Amazon, so it's all authenticated under one credentials, then you can tap in. So there's a layer, like a authentication layer. So then you can definitely tap into that.
I see. Okay.
Yeah, you cannot just go to that IP address, just where admin, well, that will not work. So yeah. That will not work. Yeah. Cool.
Great. Okay, Eric.
Right. Well, I'll jump into the MJPEG video streamer now, or the video writer. So in the video writer section, we have a tool which will write video files for you, but one of the newer features, and we're working on more of these too, is this MJPEG video writer. So what I'm going to do in the app is replace the streamer with the MJPEG video writer. And this is going to give us, we're going to lose our text interface. So one thing I really like about the SocketIO streamer is that it can link text data directly to a frame fairly easily. And so when you're seeing that text data come up on the streamer, that's linked directly to the frame you're looking at. With the MJPEG video writer, we lose that. We can still capture text data and the video data, but they'll be separate streams. So let's update this to be MJPEG video writer, and we'll just leave this as streamer for simplicity. So one thing is we're not going to have our check exit button anymore because that was part of the SocketIO back and forth. And we're going to have, let's see what we have here, write frame. And we only have frame as an input here, no text. So does that look good? I think that'll work. Let's give it a try. And so this will give us two things. So we'll still have a browser page that looks like the streamer without the text input. So we'll go ahead and start this. But also we get kind of the raw MJPEG stream available to pull in from a third-party app, or I think we can give it a try. But yeah, so this is where the video's at. Let's first open the just the page. So there we go. Now we're just seeing the MJPEG stream. Like I said, no text data. And this is kind of a, it looks a little bit like the streamer. It gives you that kind of like nice polished look, but I believe we can also go directly to the video stream and just view that. And there we go. So this is just a raw MJPEG stream. I can do one other quick example. I have VLC set up in here, and I think it should also be able to capture it. Open network stream. If you've never used VLC, it's just like a video tool that can capture network streams, record, all that kind of stuff. So let's give this a try. So there we go. Definitely some lag, but but yeah, it's going over my network, of course, with the video and everything too. So cool. So that way, a lot of different tools will be able to take that MJPEG stream. And on top of that, let me do one thing too. Let me go back to the fancier page, and let's just look at the source of this real quick. View page source. So the important part is the way that we're displaying the video. All you have to do is put the location of the MJPEG stream as the source of an image, and you'll get the video there. So you could build whatever web page you want and have this video stream there, which is a pretty powerful way to do things. So yeah, so any questions on that? I'll go ahead and stop this, but that one's pretty easy to use, so pretty flexible.
Yeah, no questions yet. So
cool.
We can continue.
So I will now jump over to the ZeroMQ video streamer example. And so it has two parts. It has, we can see here in the GitHub repo page, we have the computer vision app and the server. And there's some light descriptions here on how to use the two pieces. So this looks like that second architecture that I showed in the slides. And so what we're doing is the CV app is going to use ZeroMQ to send the images over to the server. And then the server uses that to make an MJPEG stream to display in a browser. We could do any number of things in the server. If we wanted to do additional processing on the frames in the server, we could do that. If the server were for instance, running on a more powerful machine than the edge device, and we wanted to send that to a third-party app like VLC, we could. I just chose to send it up to a browser to make it easy. So let's take a quick look. Let's look at the server first. So it's really simple. I love the simplicity of it. So what we're doing here is, this is a Flask server, and we're creating there's a package called image.zmq, which is a wrapper on PyZMQ specifically designed for sending images. And we're using, it has a request response and a pub sub option. And because I prefer to go with the non-blocking approach, we're going to use the pub sub option. So basically the server is just subscribing to this stream from any clients. And so we're going to set request response to false. And so we have an image hub here on the server, and I'm setting it to a configuration variable so I can access it in the other functions. And then what we're doing is creating a video endpoint, and this is just like how the MJPEG streamer works on the server within EdgeIQ to some extent. So we're returning a response where we're generating a video feed with this specific multi-part type. And so what this gen video feed does is it waits to receive an image from the image hub and then encodes it as JPEG and yields it to the multi-part response. And this is, you'll find examples like this all over the web. I think there's some, I saw a lot of this from tutorials on I think there's let me see. JPEG stream. There's a really good tutorial on this. Yeah, so Miguel Grinberg has a lot of stuff, and so he has a lot of good notes here if you want to learn more about this. So for this example, his doesn't have the image ZeroMQ part though. He's just generating the video stream directly in the Flask app. But in this case, this Flask app is our server, and so it's running independently from our video stream capture and computer vision app, which is running on an edge device. So I'll run this on my laptop, and we'll just call it, okay, so we will follow the instructions. So I already have my virtual environment going. So I'm just going to do time, and it should start up, and let's see. There won't be any video stream up there yet. Okay. So we'll let that go. This is the computer vision app. And so the main part looks really similar to what we had before, except I have this option here to use the embedded streamer or to use this new computer vision client that, that is written above, and we'll look at that in a second. And what I did is I gave this client the same interface as the streamer from EdgeIQ, so it's really easy to switch between them. We can see, even though not all of the things will work, like the check exit, we scroll up there, a bunch of stuff just as pass, but just to keep the interface the same and keep it simple, I did that. So what we're going to do in this CV client is set up the server address and server port, and then attempt to connect to the server using the image sender class here, and we're setting request response to false again for pub sub, and then every time we call this send data, we're going to send an image. And so image ZeroMQ gives you the option to send a short string with your image, and right now I'm not sending anything because I have kind of a one-to-one, like a one camera to one server. But what you can do here is you can actually have, and the example in the image ZeroMQ repo does this exactly, is you could have multiple devices and they could identify themselves by this short string at the beginning. So you could initiate each device with an index or something like that. And that way the server could display multiple streams, and image ZeroMQ is efficient enough to do that. I think the example they give has 8 Raspberry Pis providing a video feed in. So, and the server is handling all that, displaying all the streams in real time. So super cool. A lot of stuff you can do there.
And Eric, have you tried this with video RTC?
Sorry?
Have you tried this with video RTC? So it's like video real-time communications, I believe.
With WebRTC or video RealTC?
WebRTC, yes.
Video, I haven't heard of video RTC.
Yeah, WebRTC.
WebRTC. I have not. So that's definitely on my list. But yeah, I haven't explored WebRTC yet. But yeah, I really want to. Okay. So that could be, because right now what we're doing, that MJPEG is getting the last link up to the browser. There's definitely a lag there. So like, you could design your system in a few sort of ways. So right now we have a really fast and low latency connection to the server. And if the server is where we're making decisions, then that may be good enough. If you need to make decisions at another app, then you want to make sure that's also a low latency connection. Right now, the connection to the browser will not be super low latency, but I'll just be watching it. And so I'm not a machine that needs to make like sub 1 second decisions. But I think, especially in video conferencing and stuff like that, you would notice the latency a lot more between 2 people talking back and forth. So that's where WebRTC probably really shines. Yeah. I think it could be powerful for these apps as well, just to kind of get a lower latency connection up to the browser as well. So in the future, we'll try and get some stuff together for that, because I'm really interested in how it works. Perfect. Any other questions?
No, that's it.
All right, so let's see. So I think I covered everything in here. I have some arguments to the app, which are described in the documentation here. So you can set a different camera index, which I'll actually have to do, and a different server address. So let's give this a try. So this double dash with nothing after it instructs the AlwaysAI CLI to send the following arguments through to your application. So it's not taking them as direct arguments, but they're being passed through. So that's what that is for. Camera 1, because I have 2 cameras connected to it, and then trying to remember. I think this is the IP address of my laptop. We will give it a try and see if it works. Capture. Okay, so it didn't like my camera index. Let me just try 0 and see if that does better. Well, let's go and see what I had in this app because it worked. So I had webcam video stream. Maybe I am using the Jetson video stream here. No, it's webcam video stream. Wonder what happened. Let's try starting this one again and just see if something, or you know what, I needed to do the app install. Maybe I missed that step. You know what, I think the problem may be that it's trying to run on my laptop and not on that, so.
Do you think you have a couple extra dashes by the camera? So if you scroll up?
No, so that's what I was explaining. Those extra dashes indicate to the AlwaysAI CLI that everything following that is an argument to your Python application. The problem that I had was that it was trying to run on my laptop instead of on the Xavier NX. So I'll switch that around. Yeah, because the camera is in use for the for the webinar, so that was the problem I ran into. But I forgot that I didn't configure this one. I was testing it directly on my laptop before this, so that was where my problem was. So let's install. Should be pretty quick. Guess I didn't install this one on the Xavier NX beforehand. So it'll take a minute. Now, the first install can take a little bit of time setting up all of these dependencies. After that, it works pretty quickly, kind of like when I did the last app. So now we can try the same command as I ran before, and we'll try camera 1 again. And cannot assign requested address. So I don't think it likes the IP address. So let me double check. My IP address is okay. Looks right. So I'm going to do a quick little debugging. I'm going to go over to work on the Xavier, so I can do AI app shell, and that will open up a shell over on that device. So this bind address already in use is indicating that the CLI is already running something, which, okay. Not sure why that's coming up. Oh, maybe we'll figure it out though. No, that's not helpful.
I think AB has a suggestion.
Sure.
So I would just say, just reboot your the Jetson. I think so.
Okay.
Maybe.
Yeah, let me try just, okay, yeah, we have access to that, but it doesn't think I wonder if, yeah, so this seems to be.
So maybe there's already one container which is running and which is using the same port. That's why it's not able to bind it. So if there's some app running, so if you log into that and just maybe reboot or just say Docker restart as well, that
Yeah.
also will stop it.
There's nothing,
No,
nothing there.
nothing there. Yeah, that's interesting. Do you netstat -a?
Huh?
Netstat -a, netstat.
Oh,
Sorry.
yeah. Oh, you know what's going on? It's because it's competing with so this is running on port 5000 on
So
my own laptop, and then it's trying to use port 5000 for the streamer, but we're not using the streamer. So actually, I think that's okay. So one other thing I can do just to get this working is disable my video. How do I even, oh, here we go. So I'm going to turn off my video here. And then what I can do is just run it on my local computer. So I'm not sure why that's not working, but it should work. I think, yeah, this is not using the CUDA stuff. So, and it should be fine with the defaults here. This. Okay, what's the error now? No such device. Okay, let me try. Maybe it needs that explicitly. Oh, I think it's working. There we go. And it seems stuck. Maybe it's funny, these things always work just fine until you go to demo time, but let's see what's going on here. Not sure why it's stuck. It's like one frame at a time here. Let's just try stopping this. And okay. Yeah, we got some kind of weird error here. Let's just restart the server and see both these pieces and see if we can't get it working better. There we go. Not sure what happened last time, but definitely some fun errors I can dig through later. So yeah, so you might see that this is actually like pretty low latency, especially compared to the last demo I showed. It's looking pretty quick. And well, part of that is because it's running on the same machine. So I guess it's hard to compare. Before we were running on the Xavier, so we were dealing with network connection there. But yeah, I will sort out why that remote device step wasn't working. It should work, but and make any updates to the repo if necessary. But yeah, that was all I had lined up to demo. So if there's any questions or people want to try stuff out, or if you want to sit around and watch me debug this remote app, you know, all those are fine options.
Okay, so at this stage, we'll take any open questions. Or if you want to watch Eric debug the app, you can vote in the chat. Okay, and in the meantime, okay, everyone wants to debug.
Want to debug? Okay. Yeah, so it might be due to the IP address, because it looks like localhost itself wasn't working and wanted to use this like So maybe what I'll do is instead of doing localhost, I will try just using, telling it to go directly on my machine. I don't know if this will work, but we'll just try doing that. So we'll run it here. I'll switch this one over. It seemed pretty picky about the IP address that was provided, so that's why I'm going this direction. Since it's already installed, it should be pretty quick. I'm not going to let the server run for a long time on its own this time because those weird errors came up. We'll avoid that.
So Eric, I believe there's a question that I think was already answered. So it's what kind of setup do you have? Eric is using the NVIDIA Jetson NX with a webcam.
What else could we try? Let's see. Maybe something weird is going on with that port. Let me change the port that this is running on. So the image ZMQ, so the ZeroMQ port is 5001. But I have this app actually running on 5000. Let's just move it to 5002 and get rid of that warning. And we'll also fix this log. So we'll get that going. And now try this again. Shouldn't get the warning this time. We'll see if that fixes anything else.
Yeah, that's a good suggestion by Steve. Maybe Will can go in the source code and help Eric also debug. So if any of you have ideas of how we can debug this, feel free to let us know.
Yeah, but not super familiar with the ZeroMQ stuff, so probably something probably something simple that I missed. Only so many options though, right? It's just IP address, and then I mean it could be that it can't access it from within the container. I don't know. Should be fine. It's mounted to the network of the host. What else can we try?
Let's see. I think AB has some suggestions.
Eric, I have a question here.
Sure.
So you try to keep the interface of the streamer and your new CVC client, the same, right? So yeah, by default, I think it is listening to 5000. So if you can we pass an argument there, so to change the port altogether, so it's something different, and then you try it out maybe? Because the bind error is mostly related to port numbers.
Yeah. Are you suggesting trying 5000 here?
Yeah. So basically, in the CVC client, in the CVC client constructor where you initialize, I think you're just passing the server adder, right?
Yeah.
Can we pass some like a different the port as well to basically what I'm trying to do is like change the ports basically on both sides to maybe increment them by 10 or something just for.
I think that, yeah, I think that's a good idea. The first thing I'm going to try is switching it to what the streamer usually expects.
Okay.
Nothing doesn't seem like this should fix it, but it's worth a try, I think. Considering I'm pretty stumped on this at the moment. So that's still on 5002, but well, maybe it's doing something. I don't know. Nope. Yeah, it's just not binding. I don't know why that would be happening. Why is that? Oh, I didn't do the app install. Let's make sure that we're actually doing the right port number. Yeah, I don't know. I don't have.
I think this should be homework for the development community there, and they should come up with the solution. So
exactly. So this
what I
was
did wrong.
posed as a question for Hacky Hour trivia. So come prepared to answer it.
Yeah, it seems like switch this back. Try one more time, but we're getting repetitive here, so. Yeah, strange. I'll have to do more digging. I don't know. Any other questions?
No other questions, but I did have a quick announcement, if that's okay.
Sure, I can stop sharing my screen.
Perfect.
How do I even do that? Oh.
So as you guys know, we are launching our paid subscription plans by mid-February. So I just wanted to share the details of that and give everyone here an opportunity to ask any questions. So later on in February, we're going to be launching our basic and premium subscription plans. And the basic plan will allow users to have one user available on the project. And then the premium would have 3. So you can have a team collaborating together, and you can have between 10 and 35 production devices, which will not need to be auto started. And this will also give developers the access to the model training toolkit, the public models and the private models. And then we all get a little stuck sometimes. So support. So we'll have standard and premium support for our community, as well as the ability to log tickets for any issues or any support you might need. So check out our pricing page, and feel free to reach out to me if you have any questions about that. So does anyone else have any questions about subscription, what we shared today? If not, we can end a little bit earlier. I'm okay with that.
Looks like we've got one question that's asking how to debug the AlwaysAI app from within the EdgeIQ webcam video stream block. I mean, it's a very rudimentary way of, hey, V, hi. It's a very rudimentary way. You can always add print statements and write out images or, shapes of like images. I don't know. That's usually the stuff I end up doing. There's probably a more sophisticated way to debug. I don't know if Eric, you use anything more sophisticated. I also like to try things out like in the Python interpreter ahead of time if I'm trying like a new way of manipulating something, or if I want to like test how to get labels out of something. I don't know, did that answer the question, or you can unmute yourself or sorry, raise your hand or type some more. Yeah, sorry, I've been kind of just lurking here. I didn't know how to solve that problem that Eric was encountering. I was thinking like, yeah, maybe it's just that the ports, and that's as far as my brain got. So I've been
there was one comment earlier, and I might have already said this, but when our CLI automatically mounts network equal to host for the Docker container, so we shouldn't have to worry about setting up specific ports or anything like that on the Docker container itself. But it works the same. So I ran it on my local machine, which is a Linux machine, so it's also running in Docker, and it worked there. So something strange is going on, but we shouldn't have to worry about setting up the port on the container, though.
But when we do another session around video streamers, maybe you can just cover how you solved this problem, just so it's not a cliffhanger.
Sounds good.
Maybe it was just, computer gods deciding to mess with us today, and everything will just magically work.
Right after this call.
Yeah, that's usually the case. Yeah. Someone put in Murphy's Law earlier. That's always the reason why things didn't work.
Yeah, and hey, Abby, did you have something to add to that?
That's quite possible, as you said, that it might work after the call. But yeah, just off topic, actually, I wanted to say something. The last time's Hacky Hour, somebody asked a question about Rubik's Cube, right? I forgot about to post it on Discord, but I have the library here. I just posted in the chat window. So that's the OCMBA library, which can help you solve the Rubik's Cube. It just needs the state of the what's your Rubik's Cube state is, and then it will tell you, like, based on the faces, like which face you need to turn, and basically it gives you just steps, and then you just follow that steps, and it will solve the cube. So for solving this problem in computer vision is that, like, you have to scan your cube in all sides to give you the state, and it will create a matrix of it will it detect the Rubik's Cube, isn't it right? So it's not an AI, it's just computer vision here. So we have to just scan the cube. Basically it will identify the colors, and it will create that matrix, which will be an input to this algorithm, and this algorithm will give you the steps. So that's how it is orchestrated. The video, which is always on the YouTube, it's all the fancy piece on that. So, but there's like you have to read through that library, and it's very nicely articulated, very much documented as well. So, yeah, that's what I was planning to write something and send, but I was not getting time. Sorry, my weeks were very, very busy. So yeah, but this is the library. I've just did some work on that, and then I just had to leave it back. But yeah,
Cool.
it's pretty interesting.
Yeah, Apis, I hope that's helpful. The link is available in the chat for all attendees if you want to check out how to solve the Rubik's Cube problem.
Okay.
Great. All right, so if there's no other questions, I just want to thank Eric and Lila for joining this Hacky Hour. And
Really just Eric today. I know I was not helpful.
As well, very helpful, especially towards the end. Thank you so much for the community. Thanks for being part of AlwaysAI, and we'll see you next time.